CEO and co-founder of Near Security. Until a couple of years ago, I was doing a lot of DevOps, DevSecOps, corporate startups, and my last role, I've been in Microsoft. I led a group of DevOps and DevSecOps engineers in the Cloud Application Security Group. And eventually, over there, what happened is we been hit by the SolarWinds attack. And my team was part of that incident response. And we sat down, we looked at our pipelines and said, we have a bunch of tools on our security lifecycle, in the development lifecycle. If something like that were to happen to Microsoft tomorrow, are we protected? And the answer was no. That was the trigger for starting the company. Other than that, I'm a very cat lady. Really like music, drummer, but get lots of like loves. Where's that? It's fine. Okay, so before we dive into the actual attacks, let's go through the vector itself. So I think the main reason we're seeing the increasing amount of attacks in the recent 5 years comes from two reasons. One, I think most of the code we use today is open source. So that's a lot of risk because I guess we have a lot of application security people, security professionals in the audience, and for you understand that we spend a lot of time on triaging, and application like open source security cannot be as strong as the enterprise security because people develop open source for free. Most of the open source is free, so we can't expect them to have the same amount of security or the same level of security. The second thing, the incentive is very big. Just think about it. When I attack one company, right? Somebody attacked SolarWinds, somebody attacked an open source package, I get to tons of other companies. What are like other options I have to get such a result if not doing a supply chain attack? Now today we're going to speak on complicated attacks and complicated malware, but that's not like that's not always the use case. A lot of the attacks we've been seeing in the recent years are pretty much going to be script kiddies uploading a library to 2npm or PyP and trying to typo squat, like you can use a package name request and then I can add another S or replace the S with the Z and try to manipulate developers to download that. And it actually works. But today we'll look at attacks that are a bit sophisticated. Just before we start, most of our lives work around vulnerabilities. What's the main difference between vulnerability and supply chain attacks? So vulnerability is usually a mistake, right? The developer writes code, he or she can do a mistake and create an exploit, right? That's not deliberate. Eventually somebody identifies it, so maybe we have a bug bounty project or something like that, and we identify that with our solution on premise. Eventually, it will be identified with a CV. When you have a supply chain attack, it's a deliberate attack, right? There's no CV identification, so people speak about, for example, the exutils attack that happened. That's an intentional attack. Until somebody, like a developer, actually found it out, there was no CV around that. So until that, no tool could have identified that. It's a big problem. By the way, Log4j is not an attack. Log4j is a 0-day, which is a big difference. It's a vulnerability. Was identified and then had to be fixed really, really quick, but it's still a mistake. It wasn't deliberate attack. We have a lot of options on where to execute their supply chain. So if we're looking at the software development lifecycle from development until production, that's where I kind of stop. Production is a whole different thing. If we're looking at the developer section, we have, let's put aside if we have an internal intruder, right? If we have an internal intruder, probably doesn't matter what we're going to do. That developer will get to his crown jewel and be able to attack. But if, let's say, we have a developer that submits a vulnerable code, that's identified with just a normal SAST tool. Let's put it aside, that's not an attack. An actual attack, it's the executable attack that a developer actually submitted malicious code into the repository, right? In the form of binaries, which was a bit tricky, but that's an attack. Compromise of source control. We're not seeing a lot of those because unless you're using TFS or SVN in your organization, which in this case, I highly suggest you quit. The source control is a pretty strict environment. The Git is a pretty secure product, and we're not seeing a lot of attackers trying to actually attack the source control because it's visible. It shows in the Git history, and we don't want that. We want to be stealthy as attackers. So we will talk about some kind of attack in that section today, but not something like that. And then we have the build platform. This is like a huge case because we've seen that with SolarWinds, we've seen that with FreeCX. If I can get like a strong company that delivers software to many, many companies and somehow get to their build environment, right? Bypassing CI/CD. That's a lot what happens with the source code. Let's say I now try to spearfish an open source maintainer, and I get his credentials. And then with his credentials, I can upload the package directly to the repository. The source code is totally legitimate, but then we have malicious package directly on the repository level. Again, we won. And the last thing is compromising the actual distribution server. So we have CDNs that distribute software. We have something like what happened with the executils, with the Jump Cloud attack, when somebody managed to get into Jump Cloud and actually compromise their command server that actually shoots the agents' data into all of their agents. So again, it's a big win, and it's really hard to detect it. It's way, way before even the development lifecycle. And eventually, using of bad packages, that's everything we kind of spoke about, like multiplied by 100, because we use so many open source packages, and those packages use other packages, and eventually, if you remember, 5 minutes ago or so, and if I attack the last package in the chain, and this is the weakest link, I'm able to get all the way up to the most secure company there is. And I think this is the main problem. It's hard to say, but eventually, when we'll give developers the option to choose a package, what they will do is they will choose probably the package with the most downloads or whatever they heard on the internet, but they're not necessarily will choose the secure package, right? They will choose the first open source. And myself, I see myself as a very security-oriented when I used to do engineering. But when I needed to deliver eventually, I would choose the first one. Let's go to the attacks themselves. Let's start with a vector I like. Why? Because it's very, very simple on one hand, but it was stealthy. So let's talk about VS Code for a second. I'm not a big fan, I have to admit, but at least according to 2022, it's still considered a very popular IDE with 70% of usage, and I don't believe it has changed a lot. Now, what's good with the IDE? We store code, right? Sensitive information. We store environment files sometimes, which contains credentials. Sometimes we even deploy from the IDE. That makes the IDE a very, very sensitive and highly attackable place. What makes VS Code so good? The extensibility, right? It's not that you get an IDE, you can develop Python with VS Code, you can develop Java. Again, I'm not a big fan because I think it's still lacking. You can deploy from the IDE. You have so many extensions that you can actually use in your IDE. It makes VS Code such a good IDE, and it's free, right? It's free. I want to focus on a really nice attack that, it's not the first time that attackers, there has been a research in this area, for example. But I chose this specific attack that has been done by Amit Ashraf. And The reason I chose this one is because it was very recent, from recent May. That's one thing. And they managed to get to public companies like, and with like very, very, very big names that unfortunately weren't disclosed. And what they did to get that, they said, okay, we're going to create an extension on the VS Code marketplace. It's going to be malicious. We're going to take the Dracula theme, which we all know of, right? It's the dark theme for, the dark theme for IDE for VS Code, and we're going to change it to Darkula, right? And it seems even, it makes sense, right? It's like kind of pun intended. We're going to change Darkula to Dracula, etc. And the interesting thing that the only thing you need to do in order to be an official extension on the VS Code marketplace is one, hook up your domain name, which you can't really see here, but all you need to do is register a domain name. It doesn't have to do anything, be official, just a domain name. There you go. You can put any source code repository you want. So the extension itself, the package extension, can be malicious, but the source code, you can put like the most legitimate source code in the world, nobody would know about it. That's it, you're a verified extension on the marketplace. You can go ahead. So what this guy did, he said, okay, I'm on the IDE. What am I going to do when I'm on the IDE? Whenever a developer downloaded my extension and is going to open it up, I'm going to send it my command and control center. This way I have their source code, which is again, cron jupyter. And immediately, like in a matter of a few minutes later, they already saw the first victim. And they said, okay, it's very, very interesting. Let's try and get it more popular. So what they did, they just wrote a script that installed the extension again and again and again and again. And there's no restriction, right? There's no restriction like YouTube when you can it identify that you're trying to kind of like a video more than one time, right? So you can basically increase your reputation. And then after a few days, they became one of the most trending extension on the market, with hundreds and thousands of downloads later on. And this way, they managed to get to a lot of companies, hundreds of companies. Among them, again, is IPO companies and worth billions of dollars, including one of the justice networks, like Justice for Networks. Now, what is the problem with VS Code? What is this problem? We have a few problems. One, the extension executes on the same permission level of the IDE. Now, if you do that IDE on ADR, it's all good. Like it's signed, it's Microsoft, it's all good. But then every extension operates on the same context. So that meaning that I can do the most malicious extension, and the ADR wouldn't care because it's considered as trusted. The second thing is the permission mechanism, meaning that I can build a team extension, for example, and then the team extension can access files on the operating system. Doesn't make any sense. Doesn't have any permission like you have on your iPhones or Androids, where you can actually say, okay, do I need to actually use the camera now or not? And the last thing, it can automatically update behind the scenes. So I can, let's say now I'm downloading a very legitimate extension. Tomorrow it can be malicious because it will update behind the scenes and you wouldn't know about it. How do we protect? One thing is to educate developers. I am a big believer, I'm not a big believer because there's a lot of change of people in the organization. So it's a good thing, but eventually you might do that, but the human factor is the most important one. So we need something to be able to block it. The second thing would be to block VS Code network access and install extensions manually.
Downstairs.
Nice thing, I don't think it really solves the problem because we can download that as files and still install that. And the last thing would be to use an extension scaling tool. So these guys actually develop a tool that you can install as an extension, not malicious I/O. And then you can also submit that with an API call and ask that scanning tool is it malicious. It does a bunch of heuristics like, let's say, a theme tool can it access the file level, and it shouldn't, right? So they're doing a lot of like behavior analysis to detect malicious extension. This one still considered again very easy method. You can see anyone who actually do that today. Let's speak about the source code management. So again, as I mentioned, there aren't a lot of attacks on the source code management. I'm going to run it very quickly, just to give you a vector that might be an indicator that somebody is trying to compromise your source code management. So on GitHub and GitLab, although GitHub already fixed it, when you go to a repository, even for Microsoft, NVIDIA, one of the drivers, and you put a comment, and you upload a file to the comment, you don't even have to publish that comment. What happens is you get an official repo URL. So it's very, very critical. You can upload malware to that repository. You'll get the Microsoft URL, and you can publish malware through that. So we've seen malware from CheatLab. What they're doing is basically they uploaded malware that sits on the official VC package repo for Microsoft. What that malware does is credential harvesting, and the way they try to manipulate people to download that, they put it on YouTube and some gaming forums, etc., and they made a lot of people actually download that malware. Basically, and that's what you gave him the credibility, the Microsoft repository. Now, the way it works, in order to not be detected, and here we go into the theme of the APR again. They're saying, okay, we're not going to compile that. We're going to put a text file, a README file that contains bytecode. It won't be detected by EPR and antiviruses. And as soon as we execute the setup, and that setup is signed, that setup is trusted, it's good. And we're going to sideload and compile it on runtime in order to be to not be detected, which is an impressive method actually. So I still left this one, but it's not updated. Luckily, Microsoft did a nice thing with GitHub, and they said, okay, we're not going to give that the official repo. You can still upload a comment and the malware without actually posting the comment, but the URL now, what it's going to do, yep. Oh, no. Thank you. So what we're going to do is to change the URL and put it as the user URL instead of the repository URL, which makes much more sense because it's really hard for Microsoft to understand, okay, which file is actually malicious if it's not being detected by like virus total type of scanner, right? So you can still upload malware GitHub comments. The only way basically to evade that is if you find the malware on your repository, you need to contact GitHub. You cannot delete it yourself, the malware itself. You can disable comment on your organization. I don't think that would work. And again, if you have any repositories that needs to be private, leave it as private. Only public repositories because it's open source or something like that. Right? Don't just put anything out there. The most interesting part, the execute build vector. I'm not sure how many of you heard of it. It happens a few months ago. Big thing that big attack that happened. Although I don't know why did specifically this one got so many headlines, because we've seen something very similar with NPM packages in the past. Maybe because it's a bit lower level, maybe because it's not just an open source, but it's an open source that's being used as Java packages as well as Linux packages. So, and as I mentioned, we have much less sophisticated use cases for the same thing. We can take the Ledger use case, for example, and the UA parser attacks that happened in 2021. Basically, somebody took over a maintainer, uploaded a malicious package to the repository, and that's it. Millions of downloads. In that case,
the attacker was much, much more sophisticated. I think it was like nation-state attack, but there are no proof of that. But let's start from the end. The guy who actually detected it was a developer for Postgres. He, for some reason, he saw that he has like CPU cycles, too long CPU cycles when you're trying to log into his SSH. A developer, why would he even do something like that? And he raised the flag. He told like, listen, we have a problem here. I'm seeing like a high CPU for my logins, and it takes 8 seconds, which is a lot for an SSH login session. So now going back to the beginning, what is xutils? Just a simple library to do compression and decompression of files and a whole bunch of data streams. It's being used by a lot of software, whether it's an application, as well as operation systems, specifically on Linux. The way the attacker worked is actually very, very impressive. So we have the open source maintainer, the original one, and he gets like frustrated with life. He has a lot of work. He can't, we spoke about the open source security. It takes time to maintain open source, right? And there are few people that started to open bugs and feature requests and issues, and all of a sudden the developer says, listen, I'm going to give my keys to this guy that's been helping me for a while and been pushing fixes and a lot of new features to the repository. I'm going to give him the keys to the repository. Now this guy stays stealthy for a while, and then all of a sudden, what happens is that we see two commits. One commit with two files, two binary files that try to identify as test cases. Now, we can't really inspect binary files, right? It's on the repository. You don't really know what they do. And that was the trigger of the attack. And he did it after a lot of time, gained credibility for that repository. And then what he did, really high level, I'm not going to go into all of the details. If you want, I will be happy to share the presentation. There are all of the details in the speaker notes. Basically, he said, as part of the build process, I'm going to use those binary files to extract malicious code from those binary files into the make file that is used to build the project. And it's going to inject malicious code into the final artifact. So that means that, again, the source code is legitimate, yeah, but eventually the end result is malicious. How do we detect those kind of things? After doing that, the maintainer he reached out to the most famous Linux distribution, Fedora, Ubuntu, Red Hat, and he said, listen, I have an important fix. Please, please, please merge it. So it took a bit of time, but not all of those distributions managed to merge it before it was detected. But the distributions you see here on the screen actually use that malicious package. So let's move to a short demo for a second. What we did, we said, okay, let's try to imitate the same kind of behavior and see how long we can try and evade the authorities, right? So we took the XZ library as an implementation for Java. So we forked that, and we put some malicious code into that and uploaded that to Maven, which is the Java package manager. And we wanted to see how much time is going to stay there. So this is the package. It's been there from May. We've manipulated with the malicious code a little bit. The last iteration was in August 1st. It's still there, right? There's malicious code on Maven that we've uploaded. It has 0 vulnerabilities, as you can see. And basically what it does. So as I mentioned, the XZ library, what it does, it helps you with compression and decompression of files. So we took that, and there's a nice product called Dem Vulnerable SCA. And we used that, and we injected the library into that, just included the malicious package in the POM file. And then we created an API. That API gets a file, a zip file, a normal file, and then it zips it. And then what it does, as soon as the library is called, the malicious code is executed as well. So let's see how it looks like. Basically, I'm going to start the application that is using that compromise package, which is comprised of just 2 Docker containers. If it's not going to work, it's because demos never work, and it's not my fault. Okay, let's see the containers. So this is the container that we've included the malicious file in. And let's go to the temp folder for a second. And you can see, it doesn't contain anything interesting. So what this malicious code is doing is, again, as I mentioned, when we upload, we're going to upload and execute that API that I've just shown you. What it's going to do is basically take that file and execute a zip command on that. So let's do that. Great, the file is there now. And now we're going to activate the opportunity because the malicious library is now executed, right? Now I can run remote commands on the computer. Let's try that. I'm going to telnet to my container, and I open the tunnel now, a reverse tunnel. And what I'm going to do now, and we can see, by the way, on the container, still, we now have that eval file that we've created as part of that. If we look into this file, it's empty, right? What we will do now is that we'll put a file that will be executed, a command that will be executed. And as soon as we close the telnet session, this file is actually executed, and what it does is just executes my command. Sorry. It executes this command, and in this case, it doesn't do anything malicious because we wanted that when somebody downloads that, nothing malicious would happen out of the box. We will need to run commands on that. But in actual scenarios, somebody can just automatically create a command that will be run, and that's it, game over. And again, it's still on Maven. So that's a very complex situation. What you don't see here is that we now have the binary code and the source code in the repository. Now, the binary code contains malicious source code. The source code itself looks legitimate because the same way you see on the VS Code, the VS Code extension, the same in Maven. We can upload a binary. The source code can be different repository. We don't really have to put it as something that is very tightly coupled. How can we detect those kind of attacks, like bad open source? You can use SCA. The problem is if you remember from the beginning of the lecture, vulnerabilities and attacks are very different. So your SCA tool will detect vulnerabilities, and it wouldn't detect attacks. The second thing, you can scan for malicious code in the open source repository and binaries. There are multiple open source tools that try to do that. The problem is that we have a lot of heuristics here, and not necessarily it will be that easy to find. Second thing, I think, or third thing, when you look at one of the heuristics that you can look at is that open source shouldn't contain any binaries unless there is really important use case. In the use case of the executils, I would say, why is it pushing all of a sudden after so many years? Why is it pushing binaries to the repository? And the last thing would be attestation. This thing has gained a bit of traction in the last year or so, but I'm not seeing a lot of adoption yet. Basically, it means that when we write software, every single step of the pipeline, every single step from the code to the package level, we sign that. We say, okay, this is what we expect to see from the previous section. So from code to the CI/CD all the way to the package. So this way we can guarantee at least that the package is identical to the source code. And this helps us detect those kind of attacks. But again, I'm not seeing high adoption because it's very complicated to implement. Basically, I will go really quickly to the latest vector, which is the CI/CD. So we've seen code, right? We see code repository, malicious extensions. We've seen bad open source. But what about the CI/CD? I have a few tips there. Let's take the 3CX use case. 3CX is VoIP software used by 600,000 companies across the world, biggest names in the industry, and it's being attacked in 2023. And basically, the software, the CI/CD has been injected with malicious code, and then it was used by the customers that downloaded that update. The interesting thing about 3.6, it was a double supply chain attack, and the intention was to get to the build environment eventually. How do we do that? So the first attack vector was an employee, for some reason, downloaded a software to his computer by trading software that was discontinued in 2020. Why did he do that? So nobody told till this day. The thing is that what it does, it opens a reverse proxy on the machine, and it allows the attacker to get to the organization and start his way all the way to the build environment. So this is the first attack vector, and he's been doing that again. By the way, look at the technique. You mentioned, you remember I mentioned the signed executable. Same way, signed executable, trusted, but what it does side injection, side loading DLL, and those DLLs are running in the same context of the trusted executable, but they contain malicious code eventually. So they evade the EDR again. Great. So now he has access to that person, start traversing the organization, and eventually he managed to get to the build servers. What's the problem there? The build servers are persistent. They're not containers, they're not Dockers, they're basically servers that are actually building the Mac OS build and the Windows executables as well. And he injects different well-known shell code or malware on those to gain persistency on those build server. What happens next is basically, okay, I'm on the build server. I will wait to the next build. I will inject malicious code. And again, same pattern. We have malicious code in the binary, in the final result, and the source code is totally legitimate. How do I detect those kind of things? The malware, what it does, gets to the customer. Again, the EDR finds it a bit hard to detect because the malware is trying to stay a bit stealthy. It waits for anywhere between a week to 4 weeks, and then it executes. What it does, it's downloading an icon file which contains the malicious code, and it opens that file in order to execute, and then it just harvesting credentials from the browser, from the registry, for example, and send it to the attacker command and control center. Now, the funny thing is eventually, I think Sentinel-1 or CrowdStrike were the first, to detect those. And then a user sees that, open a ticket to 3CX support, and then the 3CX guy says, listen, if we'll answer every support ticket of a false positive by an EDR, we'll be flooded. It's a false positive. Go speak to your EDR. And then what's kind of the consequences? How can we protect? I think the most important thing is disposable build servers. If in your organization you have an old Jenkins with persistent servers, it's easy. Well, I don't want to say it's easy. It's easy to say, but it's pretty easy to actually change that server to a disposable build server. Use containers, right? Use predefined containers with whatever you need, and after you finish the build, kill the container. Don't let anybody gain persistency to that server. Second, and it's relevant not only to builds but for live general rule. Signed doesn't mean trusted. Even for Chrome, when Chrome sends diagnostic data out, it uses the Chrome binary, and then it's actually injecting a bunch of code to actually be able to send the diagnostic data outside. So there's a vulnerability for Windows that's been open since 2013, which you can actually manipulate the signature of the certificate, the signing of the binary, without being considered as malicious. The problem is that if it will be actually implemented, the fix will be implemented and enforced, that means that Chrome will be, for example, considered as vulnerable, as malicious. Few other things will be to monitor activity. I'm not a big believer in that. Too many heuristics, too many false positives. What can you monitor? Maybe you can monitor if there's a network call to a remote server you never seen before. This will probably kill your SOC. Reproducible thing, it's an interesting thing. Reproducible builds means that we're building the same application twice on different machines, and we're comparing the result checksum. Very hard to accomplish because it's enough that the version of the server or the date is different, and you get a different checksum. So it's really hard to implement. There's a big project that's trying to make it more accessible these days, but it's still very hard. And again, attestation. If I'm able to actually say when I'm building my software, listen, from the build server, from the source code to the build server, I'm expecting X. From the build server to production to the package manager, I'm expecting Y. It's a bit easier to kind of say, okay, I signed this and I know that the package equals the source code. So the last thing I'm saying, eventually, yes, vulnerabilities are a daily life, but when you do threat modeling for your software, when you're scanning the software and you're saying, okay, this open source is legitimate, try to look at more than vulnerabilities. There are other risk factors that are very, very important in the organization, and don't look over that. I have the references for everything in the presentation. That's it. Thank you so much for coming. Really, really appreciate it.